So thank you for coming my presentation. My name is JinYeong Bak. I'm a PhD student at KAIST. Actually, this research was conducted when I was research intern in Microsoft Research Asia. So here is the overview of these presentations. First, I describe about the definition of the self-disclosure and the relations with the social dynamics. And then I will explain about the limitations in previous social psychology research. And to overcome these limitations, I will introduce our computational approach for self-disclosure from data set to the methodologies. And finally, I will show the relations between self-disclosure and social dynamics in a real and large data set. So then, what is the self-disclosure? So in our lives, we have several conversations with others. And then in these conversations, we often do the self-disclosure, which is revealing the personal information. So in a social psychology, the definition of the self-disclosure is the verbal expressions by which a person aspects of self to others. So it is the process of making the self known to others. And so to analogize the self-disclosure, so social scientists have defined the level of self-disclosure: general, medium, and high level. So the general level means the general information and ideas, no information about self or someone close to him. So for example, in this conversation, so they are talking about the soccer team manager. And the next is a medium level, which means general information about self or someone close to him. It is consists of personal events, age, occupation, and family members. So for example, in these conversations, so they are talking about the mother's birthday event. And finally, high level, which means the sensitive information about self or someone close to him, such as problematic behaviors of self. It is also consists of physical appearance, health, death, or sexual topics. So in these conversations, so they are talking about the mother's accident one. And the self-disclosure has relations with the human relationship. Means the degree of self-disclosure in a relationship depends on the strength of the relationship. And also, strategic self-disclosure can strengthen the relationship. So for example, let's say two people meet at the first time, then they exchange some personal information such as name, where they live, and occupation, something like that. Then this exchange is likely to lead them to become friends. And when people do the self-disclosure, they can get social support from others and cope with the stress. For example, in these conversations, blue users are talking about the family accident. Then the green user consult him, hey, it will be fine, something like that. So those messages are social support. Then after getting the social support, the blue user feel relieved and say thank you to the green man. So until now, I introduced about the definition of the self-disclosure and relations with other social dynamics in social psychology research area. So to identify the self-disclosure, researchers mainly use the survey scheme or hand-coding scheme, but it has some limitations. Where survey, which is asking questions to participants, is biased by participants' memory, and the participants also can write to the answer sheet. And the hand-coding scheme is analogizing data set by human, but it cannot apply to the large data set because the human power is limited. And also, sometimes the data comes from the lab environment, then it is not the real and naturally occurring data set. So I built two research questions. The first one is, how can we find the self-disclosure in large, naturally occurring corpus automatically? So it needs the large and naturally occurring corpus and the new methods for identifying the self-disclosure automatically. And the second one is, what are relations between self-disclosure and social dynamics in large and naturally occurring corpus? So in a previous research, researchers are used a small data set. So can we find the new observations or results that supports the existing theories about self-disclosure in a large data set? So that's the second question of in this paper. So for real and large data set, I chose the Twitter conversations, where people in a Twitter, users have a conversations using mention or the replying function. And users discuss several topics with others, such as soccer, politics, or revealing personal information such as where they live and then family topics. So Twitter conversation is good data set for analyzing self-disclosure as a real and large data set. So I defined the Twitter conversation, which is 5 or more tweets containing at least one reply by each user. So here is the example of a Twitter conversation. So first, the Britney Spears said something to the Madonna, and Madonna replied to it. Then after that, the Britney also replied to the Madonna. So those sequence of tweets is a conversation. So I crawled and collected the conversation data from Twitter. So its size is 2 million conversations over 102K users. And now I describe about our new computational methods for identified self-disclosure, which is called the self-disclosure topping model, SDTM. To do research of self-disclosure in Twitter conversations, I had 2 challenges. The first one is that I didn't have any ground truth data set for self-disclosure level. There are no tagged data set for Twitter conversation, and there are no accessible open self-disclosure data set in a previous social psychology research area. And the second one is lack of study about the self-disclosure in computational linguistics. In a social psychology, there exists the definition of self-disclosure and examples, and the researchers mainly use the survey or hand coding scheme. Recently, one paper showed the related word categories in LIWC, but that one is a lexical form. So first, we made the ground truth data set for self-disclosure. So we sampled 301 random Twitter conversations and asked it to the 3 judges who fluent in English. And they tag the self-disclosure level to each tweet and work on a web-based platform. So right side, it's a screenshot of the web-based platform. As a result, we get the 122 G level and 147 M level and 32 H level conversations. And its iterator agreement is 0.68, which means the substantial agreement. So from the observation from the annotation data set, we came up with the 2 assumptions for our model. So the first assumption is the first-person pronouns, such as I and my, are good indicator for self-disclosure. Intuitively, it is used to describe about self, and so it was used in previous researches. And it is also observed as highly discriminative features by mutual information between G and MH level in annotated data set. And the next assumption is M and H level have different topics. Based on the definition, it is separated as general versus sensitive information about self. And in previous research, this kind of information is clustered as topics by LDA. So we assume that topping model can find and formalize this kind of information as topics. So for M level, we use the personally identifiable information such as name, location, emails, addresses. And for H level, we consider the sensitive information as secrets, such as physical appearance, health, something like that. So with the 2 assumptions, we build a self-disclosure topping model, SDTM, based on the probabilistic topping model LDA. So for classifying the G and MH level, STTM used the maximum entropy classifier with observed first-person pronoun. And for classifying the MH level, STTM used the seed words for each level with the observed words. So to explain about the STTM more easily, I draw the rough figures of how to infer self-disclosure in STTM. So first, the input of the STTM is a tweet. Then the probabilities of G or MH level of the tweet are computed by mixture of maximum entropy classifier and the topping model. And the probabilities of M or H level of this tweet are also computed by topping models with seed words. So now I'll describe about the maximum entropy classifier and the seed words in more detail. So maximum entropy classifier in STTM is learned from the annotated data set, where we can choose the other classifiers such as C45 or naive-Bayes, but maximum entropy classifier works better than others, and it is used to identify aspects and opinions in topping models in previous research. And now I'll describe about the seed words in more detail. So seed words are prior knowledge for each level. For G levels, we do not assign any seed words, so it's a symmetric prior. However, for M and H levels, we use the data-driven approach for getting our seed words. So for M levels, we look for trigrams that begins I and my and occurring more than 200 times in Twitter conversation data set. So in the table, I showed some examples of seed words for M level, categorized name, birthday, location, and occupation. And next, for H level, we use the external data set, which is the 6 billion secret site. In that site, users can write and share his or her secrets. So I crawled 26K posts and extract the high-ranked word features by mutual information between secret posts and the random tweets. So in this table, I showed some examples of seed words for H level, categorized the physical appearance, health condition, and death. Now I show the performance of the STTM and comparing with others that use the maximum entropy classifier because it shows the similar or better performance than other classifiers. The experimental data is the annotated Twitter conversation, and it is divided 80-20 training test set randomly. I also compared several methods, but in these presentations, I pick up only 4 things. All other results are written in the paper. So first, the BOW plus is a combination of unigram, bigrams, and trigram features. First P is the first-person pronoun features, and seed is seed words and trigram features. And first P plus seed is the combination of the first P and seed features. And finally, STTM is our model. And as a result, and as an accuracy point of view, STTM shows the better performance than others. And in F1 measures, first P plus seed and then STTM shows the similar performance on G and M level. However, for identifying the H level, STTM shows the better performance than other baseline approaches. So STTM is useful to identify the self-disclosure in Twitter conversation. Now, I will show the relations between self-disclosure and social dynamics with STTM in a Twitter conversation. As I said earlier, strategic self-disclosure can strengthen the relationship. So I wanted to verify that this hypothesis in real and large data sets such as Twitter conversation. So for verifying this hypothesis, I made two sub-questions. The first one is, does high self-disclosure lead to the longer conversations? Where social science states that relationship strength can be measured by communication length. So I use the conversation length as a proxy of measuring relationship strength. And the second question is that, is there any difference in conversation length patterns over time depending on overall self-disclosure level? So more specifically, high-level self-disclosure dyads will increase the conversation length over time, whereas low self-disclosure level dyads do not increase the conversation length over time. So I ran the STTM with the Twitter conversation dataset, and as a result, I can get several topics on each level. So in these tables, I show some example topics which high-ranked topics in each level. So G-level topics are related with politicians and soccer. And M-level topics are related with personal communication and party. And H-level topics are related with personal health and then property. Now I answer the two questions. So for answering the first question, I divided the conversation period into two groups, initial period and subsequent period. Initial period is the first 20 days, which starts from first conversation of each dyad, and subsequent period is the 10 days subsequently. So here I draw the scatter plots. X-axis is the self-disclosure level in the initial period, and then Y-axis is the changes of conversation length between periods. And as you can see that it shows the positive relations between them and with a low p-value. For answering the second question, I divided the conversational dyads into three parts by self-disclosure level score. So self-disclosure level score is the weighted average of each dyad self-disclosure over time. And the high groups is defined as the dyads who have 2.4 self-disclosure level score or higher, and the low groups dyads have 1.8 scores or lower. The remaining dyads are in the mid groups. And so in this graph, the x-axis is the order of the conversation, and the y-axis is the average, the number of tweets in a conversation, which is the conversation length. So as you can see that high and mid groups increase the conversation length over time, but not low groups. And high groups talk more in a conversation than mid or low groups overall time. So now I summarized my papers. First, we made the ground truth Twitter conversation data set for self-disclosure level. And then we suggest novel methods for identifying self-disclosure level, which is called STTM. And finally, we will also show the relations between self-disclosure and social dynamics in Twitter conversation data set. So, and in the future work, I will focus on the self-disclosure, not only conversational tweets, but also general messages, because the user writes the general messages many times like a monologue. And recently, self-disclosure behavior in online social network is related with the loneliness and online social network usage. So from the identify the self-disclosure in an online social network, we can predict the user's loneliness and can give the social support. Then this social support can lead to users use the online social network more frequently. So here is the reference of these presentations. So thank you for listening to my presentations. Do you have any questions or comments?
Thank you for the interesting talk. I was not sure how you determine that it is a conversation between two people.
Okay. Oh, sorry. Yeah. So actually, this tweet is just mentioned to the Maruna by Britney Spears. However, all other tweets are using the reply functions in a Twitter conversation. So as you can see in the Twitter, so there is a reply to the, something like that for this tweet. So I make the sequence of the tweets and then make them into the one conversation. Yeah. So actually it's mentioned, but in the Twitter side, they show that these tweets are replying to this tweet. So I can make a conversation using reply function.
And the very first one, does it have to mention anybody? Or the first one could just be, I feel horrible today, and then somebody replies to me?
Yeah. So
here you have an example where the first one already initiates a conversation, right? I say, at you, I'm feeling horrible today, right? And then you reply something or so, right? But that's not required. That's not required.
Oh, yeah. So those one also can be the conversation. Then because that one is a conversation because I define conversation as 5 or more tweets, and then this one reply by each user. So you said that, today is very tired day. So okay, well, how about that? Then okay, so something like that. Then it also one Twitter conversation.
How did you get all the data? How did you get all the data?
Okay. At the first time, I see the garden hose data set in the Twitter and find the tweets which contain the replying function. Then I have 13 candidates of the users. So from them, I crawl his or her timelines and find the tweet which contain the reply functions, and then I jump to the other users who gotten the reply function, and also crawl. So I jump the 4 times. So the depth of the network is the 4 times. That's why the user is 102K users. So, any other question?
Did you exclude tweets from multiple persons in a conversation? Did you consider only conversation between two persons only?
Yeah, okay, yeah, right. So I just focused on the only 2 users' conversations. So some tweets contain several mentions, and so several mentions, but I do not. I just excluded this kind of tweets, and then just making a 2 users conversation. Because I wanted to see the human relations between dyads. Yeah.
Did you consider using any of the social features? For example, so if there's a conversation between 2 users, right, you can see, do they follow each other, or do they have many friends in common, or does one of them have like a million followers or something? Or so, did you include some of this in the classifier?
For classing, actually in these 2 papers, I wanted to classify the self-disclosure behavior in a text message. So I do not consider about the network structures right now, but actually in a previous research, I cannot publish it to the paper, but I also consider about the network structure such as following follower or the hashtag network, something like that, but it is not related with the self-disclosure behavior and also the self-disclosure behavior, yeah, right. So that's why I do not consider it right now.
Okay, let's thank the speaker once more.